Chapter 8, Number 8. A mass is attached to the bottom of a vertical spring. This causes the spring to stretch and the mass to move downward. A. Does the potential energy of the spring increase, decrease, or stay the same during this process? And B. Does the gravitational potential energy of the Earth mass system increase, decrease, or stay the same? In both cases, explain. So let's draw what we're talking about. We're hanging a spring from the ceiling. So this is sort of the original one. And then when we hang the spring, we get that it stretches. So like that, because there's a mass hanging on it, which means that there's been some stretch. Since we know that the potential energy of a spring is 1/2 k s squared, k has to be positive, and s squared has to be positive. So u of the spring is positive, and it started at 0. So delta u of the spring is 1/2 k s squared minus 0, or 1/2 k s squared, and that is a strictly positive number, that this is greater than 0. To find the gravitational energy, we'll need a reference point, a place where y equals 0, and I'm going to choose where it started, since that seems relatively natural. That's y equals 0. So the energy at the start is just 0, or else I've just made it that way. And then the energy at the end is going to be mgy, but we can see that the new position down here, this is y equals minus s. I'm below y equals 0 by a distance s. So we get that the final energy is minus mgs, and therefore the change in gravitational energy is minus mgs minus 0, or minus mgs. And since all of these are defined as positive, the mass is always positive, g is defined as the positive quantity, 9.81 meters per second square, and s was the amount stretched, it's a positive number, this whole thing is negative. If you don't like the calculational bit, or at least the algebra bit, you can sort of think of stretching a spring or compressing a spring always stores positive energy in it, but objects that descend lose gravitational energy.